In this brief video, I'm going to talk about the axis angle representation of 3D rotations. So previously we have seen that a 3D rotation can be specified by specifying the axis of rotation in, that is the axis around which the rotation occurs, and the angle or the magnitude of rotation, so which we denoted as theta. So together the axis and the angle specifies the 3D rotation completely. Often it is convenient not to specify the axis and the angle separately, but to specify them together with a vector. Let's call it omega, which is equal to the scalar theta times the vector n. To distinguish scalar from and vectors, let me put an arrow above the vectors. So often we can specify the rotation in terms of the product of theta and n. So now, given this vector omega, we can find theta as the length of this vector omega. Since the length of n is equal to 1, it's a unit norm vector, the length of omega is equal to theta, and then n is equal to the unit vector in the direction of theta, which is omega by the length of omega. So this form or this representation of rotation is known as the axis angle representation, where instead of specifying the axis and angle separately, they are specified as their product, and given the product, they can be uniquely decomposed into the angle and the its direction, that is the axis of rotation.